Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes. So today we have to solve this question, that is maximum number of tasks you can assign. So we'll first go to the problem statement, that is tagged as an hard. And I'm pretty sure like that is obviously a hard question because identifying this kind of things is kind of complex. Literally is not on the percent, but more specifically I have to say this is not a very interview specific question. Like we have to use kind of data structure which you can solve with some DQ based visiting things, but that is not like a very general. So to apply them and to solve in a particular interview is absolutely like super hard. If you are not aware of few of the competitive coding data structure that we are generally using day to day for this. Yeah, so we'll come on that part on code iterations and intuitions building part. So first we will understand the problem. Yeah, I think the problem statement is very straightforward and clear to us, all of us. We'll go to read it once day. Yeah, and so what they have given n task and m workers. Each task has a strength requirement stored in a zero index integer array tasks with ith task requiring task size strength to complete. Very simple. The strength of each worker stored in a zero index integer array workers with jth worker having worker j strength. So they have given a task array of size n, they have given a workers array of size m. A particular task is need a particular strength, that is of tasks I amount of strength to solve it, at minimum of tasks I amount of energy to solve it, but more than tasks of I strength workers they can also solve, and they have given a workers array where workers of I basically holding what is the strength of the ith worker. It's very simple, and each workers can only be assigned to a single task. So you can assign a single worker with a single task only and must have a strength greater than or equals to the task strength requirement that we already guessed. So that is obvious also. So workers of j, that the workers you have choose to solve the task size, should have strength greater than of the task size, at least greater than equals to is also fine. Additionally, they have given us some magical pills that increase a worker strength by strength amount. They have given some pills which are magical pills. If a particular worker is going to consume that, their strength is going to be increased at an amount of plus strength. So that much amount a particular pill is going to add worker strength. Straightforward, simple. You can decide which workers receive the magical pills. However, you may only give each workers at most one magical pills. So that is a constraint also they have given. So you can't give a particular workers in number of pills. You can give one pills, at most one pills to a particular workers. Now what we have to do, given the zero index integer array tasks and workers and the integer pills and strength, return the maximum number of tasks that can be completed. Return the maximum number of tasks that we can complete. So on this example test case, you can see the give me 1 minute guys, I am running low battery. I'm just coming in 2 minutes. Yes guys, so we are back. Yeah, so where we are, so we are started understanding the example test case. So here you can see that task is given, workers is given, pills and strength they have given. So here you can see we can assign the magical pills and the task as follow. Give the magical pills to worker 0. So we can give the magical pills to this worker. Its strength is going to be increased to 1, and then we have workers of strength 133, and we have only one pills of supply. Given the magical pills, assign worker 0 to task 2, 0, 1, 2. That is the last task we can give to him. So 0 plus 1, so 0 is its initial strength, and that is the pill power, and it is going to be greater than equals to this particular value, that is of task size. So here you can see that this particular configurations we are all together achieve. This particular workers can do this. And similarly, workers 1 we have assigned to task. This particular three workers power we have assigned this task to. Similarly, 3 we can assign 3 any configurations. And finally we are able to do all the 3 tasks. On this example test case, you can see we can assign, we have only one magical pills of power 5. So we have assigned, let's suppose, of these workers, and let's suppose he completed this task. So he can complete any task. So let's suppose he complete this task and able to complete at most like one task only. So that's exactly what they are looking for. What is the maximum number of tasks we can complete? Here you can see on this example test case, we have total 3 pills. We have total of how many pills? 3 pills, and strength of each pill is 10. We should be able to do 2 tasks. How? We have assigned first pills to these workers, and its strength is going to be greater, so he perform this task. Then 15, 10 again smaller, assign 1 pills, it's become 20, right? 10 plus 10, 20 greater than 15. You should be able to do this particular task. And on the very next go, we have remaining with 1 pills, and we have to do a task with which need power 30, and we have all the workers of power 10, and we have remaining of 1 pill. So at max we can increase the power to 10 plus 10, 20, but not greater than equals to 30. So we are not able to do more tasks. So that's the reason we are able to returning output as a true here. So as you can see, the constant n and m can be of 5 into 10 raised to the power 4, which is quite high. So you have to think of kind of big of n log n kind of things, or big of n should be very great. So yeah, so that's exactly on the problem statement. I personally feels the problem statement on the very start is very straightforward, but if you are not able to understand, please go to the video once to the and the test case iterations that we did. Please go to that particular part one, you will definitely get it. And if still not, then please read the problem statement 1 to 2 times and do that in the repeated way. But yeah, on the very first goal, if you are like jump on this particular problem to solve it or to get a understanding of this, then I think the understanding of the problem statement should not be a factor. Now let's jump on the intuitions building part. So definitely though, if we are greedy, if we are kind of greedy, so what greediness we can show? What greediness we can show? So we have 2 things. We have a workers. We have an workers array. So that is there, and we have a strength array, not strength array, that is of tasks array. That is a task array which is there. So now we on super greedy, if I want to do more tasks, then which of the tasks we have to choose. Now every task has some value associated with it. X, Y, Z, A, B. Every task has some value. But what they are looking for, they are basically looking for how many maximum number of tasks you can solve. So if there is a cost factor to associate. If we are going to solve more tougher tasks, more tough tasks which are need more strength, then we are going to get more, let's suppose, cost. If that is so, then we can think of kind of different. But here we will become greedy. How we are going to become greedy? What they are looking for? They are basically looking for what is the maximum number of tasks you can solve. So we are trying to solve which of the task has lesser value. So we are going to be greedy. So I am giving you the intuitions, guys, how you can come to the optimal solution. So that is the one greediness we can show. We have to solve lesser strength task. We should be greedy, and we have to try to solve lesser strength task. So if you are not able to solve lesser strength task with the pills and the workers, then we are definitely bound to solve with which are more strength needed task. So every task is going to be equivalent here, right? Because we have to return the maximum number of tasks, right? So we should be greedy to solve which tasks are lesser value. So we are definitely sort our task array. We will definitely do sort it. Very straightforward. We need to sort it, and we will try to solve which of the first, let's suppose, k task we can solve. What is the first k task we can solve? If you are able to solve that, then we will try to expand our window. So let's suppose with the current workers we are able to solve first k task. Current workers and the pill powers, we are able to solve first k task. So then we will search. Maybe we are able to solve first k plus n task. We like this way we are going to solve. So the first things we are become super greedy. We are trying to solve lesser strength task. That is the first observations we can put. The second observations we can put after sorting our tasks array should be monotonously increasing, or I can say it is monotonous. Hi guys, Shouvik and welcome back to Leetcode. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have push comics. Yep. Yeah. So now where we are. So here you can see on the task array. In the task array, we can either after sorting it is maybe equal or it is going to be monotonically increasing. But it is for sure that all the task elements of the task array are sorted. So if we have the task array, and where all the values are sorted, so on the very greediness, what we can see, we will basically first try to solve, let's suppose, k task, if we are going to solve the first k task with the current workers they have provided and the pills, we are first going to solve the first k task. We are going, if we are able to solve it, then we will search for the right go, for the right half. If we can put our k to some more right, and let's suppose here we get, and here also we are going to solve that many tasks. So these many tasks on the very first go we are able to solve, this many tasks on the very second go we are able to solve. So then we are going to expand our window to more, let's suppose on this particular point. But here let's suppose we are not able to solve all the smallest k tasks as these are sorted, not able to solve the first smallest k task, then we have to shrink, so maybe our answer can be lied to this particular points where because our L is going to be point to here and our R is point to be here. So here maybe at some points we will get the optimal points of k, where with the current workers and pills, you are able to solve that many k tasks. So on very naked eyes I can see I should have applied binary search on answer on very naked eyes. If you are not able to understand this particular concept, I will definitely suggest you to go to the binary search playlist of our own. We have in-depth solved multiple problems and multiple explanations I have did to binary search on answer, how you can build your intuitions. But on this particular problems, that exactly the intuitions I am going to provide you. But I am assuming that you should be get that intuitions, but if you are not, then please go to the video one more time this particular sections, and still not, then maybe you are not at the good state to solve that particular problem. That is obviously a master level problem. Setting your algo to the binary search is, you have to be very thorough to this, then only you are going to solve these particular problems. Otherwise I will suggest please go to the binary search starting videos of the playlist. After that you can maybe jump on this particular video. So very naked eyes we can see we have to use a binary search, so some of the portions we can see. If we can see till this answer is valid, so can I say till this answer is also valid, yes. So we have a monotonic segment. We need to find that equilibrium points or the identical points till of its left. All the answers are valid, and just after right the answers are invalid. So we have to find how many first k tasks, minimum strength needed first k tasks we can solve. So that is actually nothing but our answer. Now the problem is, so that template I think is very straightforward. You will start your binary search to be 0, left is 0, and your right is now before of that binary search template, give me a, if you are going to consider first k task or first mid task, more specifically I have to say first mid task you are going to be solved, then what is the workers you are going to be assigned. So you know every workers are going to solve one task only, every workers are going to be solve only one task. So which of the workers you will solve the first k smallest task if you are super greedy. The highest power workers I am going to take. So that means we are going to sort our workers array also we are going to solve, and when I am going to take the first less power task, I am going to take that many highest power workers from the given workers list, right, after sorting it. I think it's very intuitive and you guys getting it till now. So our right pointer should be at max how many tasks we can get, at max how many tasks you can get. So it is nothing but mean of your task array size and your workers array size, because every workers is going to be assigned to one task only. If your task array is small, so that many maximum tasks you can achieve, and if your workers are lesser, so that many with every workers if they can do only one task, so at max maybe n-1 task, where the index is going to be like m-1, that is the size of the workers array, that many tasks you can solve. So very intuitive. So that's the reason my right pointer should be mean of n-1 and m-1. Now I am doing our binary search, very straightforward. While left less than equals to right, mid equals to my left plus right by 1, and I am calling my helper functions is possible. Can I solve this many? I am writing this is possible functions, so I am come on that. But let's suppose we have an is possible functions. If that particular task is going to be solved, so can I say my answer is nothing but mid plus 1. Why mid plus 1? Because index are 0 based, so we are going to solve. If it is on 1, so that means 0 and 1. So first two tasks, smallest task we are able to solve, and we are moving our left to mid plus 1. We are searching to solve more number of tasks, and if is possible is going to return us a true, and else we are trying to solve less tasks our right pointer is moved to mid -1. Very standard binary search we are doing. There is no super magic, and finally we are returning our answer. So now we will discuss our answer array. Is possible functions. Now we will jump on our is possible functions. How our is possible function should be look like. How our is possible function should be look like. So I am pretty sure. I am pretty sure that what are the workers that I am considering. What are the workers that I am considering? So I am considering the first k highest power workers. The first k highest power workers, right? And what is the strength array? What is the task array I am considering? The first k smallest strength needed tasks, and we have that many pills also. We have pills also to increase the powers of the workers. So on very greedily, what we can do? How we can assign? Tell me guys. On very greedily, how we can assign? So both are sorted. So I can start iterate for I in range. I can start like what is the highest power task? What is the highest power task which is need more power? I am going to assign to the highest strength workers. I am going to assign the highest strength workers, right? For I in range, I am going to iterate to the I got a mid value here. So the last index, or more specifically, I can write the last index of the task array we are considering. From 0 to last index we are considering. So I am going to iterate reverse. I am going to iterate from reverse. So the highest power task I am assigned to the highest power workers. So I am going to iterate last index -1, not -1 because I am going to already writing the -1 index only, and -1. So I am going to iterate from the very last. So if at any particular time, if that workers, and let's suppose I have a j pointer of workers of j, right? Now if at any particular point my workers of j is less than, not equals to, it's less than to the tasks of I. So that is the task that we are considering from right. That is the highest strength needed task we are considering. And then the jth index where we are landing. So j is also going to be how it is. So you can do anything, like you can do a reverse sort or of your workers array, or you can do a forward sort only. Let me check what I did here. So I did only forward sort only. Yeah. So what actually we are looking for? So on our is possible functions, what is the if the last index? What is the last index we are considering? The ith index. So I is nothing but the task. The task power is more than the what is the highest workers of j. Workers of j is nothing but, I can write it as a -1 also. So that means the highest power workers I am considering from the the first kth highest power workers that I am considering, that workers is not able to solve that particular problem. So I think Siva is getting it, right? If you not, then let me just quickly diagram it also. So we have a tasks array, we have a workers array. So that is our workers array. So what we are doing, we first try to solve least k power task. So here are actually k tasks with the highest k powers worker. With the highest k power workers we are going to assign. Right? So if we are able to solve, if it is not able to solve, so that means we need pills. We need to feed pills to them. Feed pills to them. And so now we are going to make a performer. So then, is there any performer altogether who can solve this problem? I will make a function called find performer with the current pills number, how many pills we have, and the current values, whatever the value, and it is going to return me what is the least power performers. So this performer is going to return me what is the smallest. So I definitely need pills, right? If we are land on this particular point, we definitely need a pills. To solve this particular task. So, but we will feed the pills to the workers who basically just consuming the pills are able to solve. So there can be more workers who are maybe some more powerful workers. So just he is basically less of one power of that particular task. So that's the reason he is not able to solve that particular problem. So we are not going to feed that particular workers. We are super greedy. We are going to super greedy to solve that particular task. So I have to use a pills. So when we are going to use a pills, why I have to consume that which is already a powerful worker? So just for 1 power he is not able to solve that particular task. Why we are going to consume pills to that particular, rather than who are the very least power workers, just by consuming pills is able to solve that task. So here also we our workers array is sorted. So here basically I am giving you on high levels what we did. Our workers array are sorted, so we are considering 0 to k, that is of, or more specifically k minus 1 to minus 1, that is the highest of or more, sorry, I wrote it wrong, minus k to last of the index. So I am assuming that you guys know negative index of Python. So here we are considering the last k index of our workers array. So they are all sorted. So we are basically finding which of the least power workers by binary search on it, as it is unsorted, plus pills is greater than equals to my tasks, that tasks which are not we are able to solve. We are just want to find that particular performer, and we are going to put the pills to that particular performer. And after that, and if we are not able to find any performer who are able to solve it, we are storing in our performer array to a -1. So that means no particular performer is going to solve it. No particular performer is altogether solve that particular task. And if our performer array at any particular point is pointing to -1, so that task is not altogether solvable. We are going to return a false then and there for our is possible functions. And if it is so, if our performer is not a -1, if our performer is not a -1, so that means there is a performer who is consuming pills is able to solve that particular task. So on that particular times, let's suppose we have a local pills count. We need a local pills because we are making our binary search for every particular k index of task. And if we are using the pills array, then maybe with one binary search we are exhaust of pills. So we need a local pills, which is going to be initially we will set to the pills array, and for particular is possible functions we will consume pills from the local pills, right? And as we use the local pills, we are increasing the local pills count, and what we will do, we will remove that particular performer to our workers array, because on the very next task he is altogether occupied. As the reasons, one workers can do only one task. Now you guys might be aware of, if you are not aware, then I should definitely suggest to go to the popular sorted containers of Python, how it is working. But if it is not, I am just giving you the time complexity. So here you can see, like we have to change our elements, our size of the workers array is going to be changed. We have to discard here, because on the very next we don't want this particular workers are considered again, right? So that's the reasons we have to discard. So now how we can discard? So there is a concept of sorted container. So that sorted container is going to provide us a sorted list, which can do discard, add, everything's in log n times. This can do it in log n times. This is for Python. If you are coming from C++ background, then you definitely know about something known as multiset, which can also give this kind of like functionality by like adding, deleting in log n times. So that's the reasons I am initially stating it is on competitive coding problems. So you have to be aware of this kind of data structure, so that then only you can get an AC, otherwise not. There is a discuss sections I have read out where people solve it with like DQ kind of things, but that is extreme, guys. So that like getting that intuitions on an interview is extremely not feasible. If you are by chance going to get this kind of very unlucky and you are going to get this kind of problems, use sorted list, multisets. But before of that, please understand how sorted container or multiset actually internally working, so that you can like not on a bad state, like when interviewer going to ask you like what actually, how it is going to do in login. So it is basically use a binary search on internal also, and it is basically doing a divide and conquer. It is going to split itself to a smaller chunks when it is going to beyond of a particular threshold it can hold. So you can read on a ChatGPT on any platforms, you can read it before on your interview. But yeah, like I would suggest like on sorted containers or multiset using to this particular problems is more familiar. Yeah, so that on high levels on the intuitions building. Now I am pretty sure that like these problems you guys are not going to digest on the very first go. It is obviously a master level problem. It is obviously a super hard problem. There are multiple things is going to be associated, and that's the reason it is also tagged as an art. But I don't actually want to demotivate you guys, but I would definitely suggest please solve some kind of like binary search on answer, then sorted containers hands on you can do. Post that you can like try to solve this particular problems on your own, and if you are not able to understand, then please go to the like code iterations and please try to write the code to your own, and if at any particular points if you are not feel that you are not on currently that are not on that levels you can solve that hard problems, I would suggest you can skip it. You will be very happy to skip it. That is not going to be asked to 90% 95% of progress company at all, but there are some companies kind of Tower Research and media.net which basically try to basically deep dive in such like competitive programming data structures in depth. But yeah, like if you are not able to understand, don't be in panic situations. This problem is not going to be asked on an interview, and if you are by chance and super unlucky you are going to hit, then give the solutions on sorted container or multi-set or whichever on your preferred language. Please give the statements on that particular versions only. That should be more than sufficient, I have to say. So now we can quickly go to the code iteration. So n and m I have taken, task sort, worker sort, I have sorted them. LR should be 0, mean of n minus 1, m minus 1. Here we are doing standard binary search. Here we are doing standard binary search, right? L plus R is possible functions we are making calls. Now here you can see on is possible functions what actually we are doing. But before that, like if it is possible, then we are storing mid plus 1 and it is a zero based index. Else we are storing L equals to mid plus 1 and we are moving to make more tasks to solve. Else we are making R to mid minus 1 and returning our answer. Now every game is inside the is possible functions. Now we have started our I to the last index and we have initialized local pills to pills because we are not going to distort the pills because every binary search need a pills to validate is possible functions, like fresh all the pills. So for our purpose we have created one more variables for local pills for our performance for our use case. So we have choose performer to be -1 that we initially choose, we didn't find any performer. So now that is the case where we are basically stating if with task I, who is the highest powered workers is not able to solve it. Highest powered worker is not able to solve it. So before of that, like you can see, I have passed the sorted list of workers of mid -1 to last to the function call. So here I got a sorted list. Sorted list is altogether holding all the value in the sorted multiset, and it is also going to add and discard in big of login. So that's beauty it is going to provide us. Now inside of if it is not, then we will check if we have a local pills, because the highest rated workers is not able to solve the particular task, then we definitely need a pills. If there is no pills, return false. There is no chance to solve this particular task that we are considering. Return false then and there. And if local pills are available, we are going to check who is the minimum power workers just consuming the pills are able to solve. We are making our functions called who performed with pills. We passed our sorted list task, which is the task we are trying to solve, and the size of our sorted list. And here we are doing the binary search of our sorted list because we know it is of sorted list is inside of is itself is a sorted, and we have pushed we have initialized result to -1, LR to be 0, size -1, and we have pick our mid sorted list plus mid plus the pills power. If it is greater than equals to task, then we are going to put this particular results to be sorted list of mid. So this is the performer who is, we can say this is the performer. We find the performer who is able to solve this particular task with pills. But we will try to search for the smallest workers which pills is going to solve. So we move our right pointer to mid -1. If it is not, then we are moving our left pointer to mid +1. And finally we are returning to results. So here we are done a very standard binary search here. One binary search we did here, one binary search we did here to find who performed the pills. And let's suppose if it is not, then that means the highest rated performers is able to solve this particular task without pills. Then performer is not altogether the sorted list of -1. He is altogether going to solve that because we are super greedy. We are going to assign the highest rated task to the highest rated performer. So why we are going to come later. So we know that is the highest rated performer we have. So next task we are going to consider it should be bound to be in the less strength needed, or maybe equal strength needed. So we can blindly assign the highest rated performer to do that particular task. And after execution, this entire logic, if our performer is altogether still -1, that means this particular task is not altogether solvable. So we can return a false from here. And if it is not, then we are able to solve this particular task with the performer. So we have discard that performer so that we are not going to reuse that performer. So we have discard it and we have moved to I -1, size -1 because our sorted list is going to discard it. And if we are able to assign all the tasks, so our I is basically iterating to the task last index. So that many tasks we are trying to assign, and we have assigned to all the tasks. And finally, if we are able to do so, we are returning and so that is possible functions is yes. So that first k task first mid task you can obviously solve. Yes guys, so that's all about this particular problems. I know it is quite challenging. I tried my like super best to explain you, but yeah, like if you have still doubt, please put your thoughts on the comment sections, your doubts on the comment section. I will definitely iterate on that. But yes guys, the problem is what it is. It is kind of a master problem, and that is the deep dive or dive deep you have to do to solve it. Now on time complexity, what we are doing, like time complexity, we should be like super good. So on time complexity, just if we can quickly write it. So initially we are doing, let's suppose mean of n and m, I am considering n is the smallest, so we are doing a big of log n on the smallest one, and inside that we are calling our is possible functions. And what is actually the is possible functions time complexity? We are creating a sorted list, guys. Before calling it, we are also creating a sorted list. So to create a sorted list with first mid elements, I can consider in times of, so it is kind of in complexity of mid, it is going to be shrink on every time, that we all know. But I am writing in kind of a mid, so that many workers we need. So that is the sorted list size at as big as can grow. So it can grow. I am writing in kind of m, but it is definitely less than of m. So m log m here for sure to build the sorted lists. Sorted list building is kind of m log n, and inside that what we are doing, then we called our is possible functions, right? We called our is possible functions, and inside that we are making a who perform calls. Who perform calls is going to do a log m, I can say. Log m, I can say it is doing binary search only. So it is going to call, but take a note, this is only going to be solved when the last workers is not altogether perform this task. When we have to introduce a pill factor to solve that particular task only. So it is not going to be called every time, but I can consider it is going to be called. So we are only consider the very worst case. So let's suppose it is going to be called. So another log m factor, it is going to be incorporated to our answer. And what we are doing, and here you can see, like inside is possible functions, we are obviously running a for loop, while loop from I to last index, which is at max can grow to, if I can consider mid as big as of n, then it can grow as big as n. So n log m, right? N log m. And anything more, guys? Yes, I think so we are discarding from our sorted list. So it is also going to be taking a time complexity, or it's kind of something like this. N is I can take common because n I am iterating, and log m I am doing for every who perform functions, and I am discarding also, which is also going to be taking a log m. Yes, that's it. Mostly on the time complexity. If I can simplify it, it kind of like big O of log n cross n, then m log m plus 2n log m, and as big, if I can now multiply this, so m log n and n log it is of, yes, n log m, and if I can consider n and m is altogether same, then if I can write it in kind of 5 into 10 raised to the power 4, because that is the only worst case complexity. N and m is altogether equivalent, then it can grow big O of log n. I'm considering n and m is equivalent, so now m I can consider it's n only, n log n, and n log n plus 2n log n. So kind of like 3, what it is, n, I can write it, let me write it. So that is of n log n plus, here it is of 2n log n. So finally it is boiled down to 3n log n internally. So big O of 3n log n, right? 3n log n internally, and a log n factor. So 3n log n into log n. So n log n kind of complexity we can achieve. Now if I can put some, like if our n can grow as big as 5 into 10 raised to the power 4, so how far it is? So 5 into 10 raised to the power 4, log of 5 into 10 raised to the power 4 is kind of like, it is complex guys, it is obviously complex. 3 into 5 into So I can write is 15 into 10 raised to the power 4, or I can write is 1.5 into 10 raised to the power 5 into this log of 5 raised to the 5 into 10 raised to the power 4 is nothing going to be 16, that I have checked already. So multiplied by 216, right? So 16 into 16, 256. Now I can use a calculator for sure. So what is the final? So 256 into 1.5, 3.84 into 10 raised to the power 5, 384, right? So it is nothing coming as 384 into 10 raised to the power 5, correct? Or if I can write it more generically, 3.84 into 10 raised to the power 7, right? Which is less than my 10 raised to the power 8. So as we know, we can do as big as 10 raised to the power 8 operations in 1 second. So we are under the limit. So the time complexity of this particular problem is 3.84 into 10 raised to the power 7 at like very worst case, but that worst case is never going to be encountered because we are going to shrink our mid. We are doing binary search, so it is never going to be an m log n kind of things. But it is what it is. It can take that is the maximum times, but we are still good. We are still within the range of 10 raised to the power 8. Yes, guys. So that is the most optimal time complexity I am able to achieve for this particular problem. So on space perspective, what we are doing, in place, everything is in place. We are creating the sorted list, which is only going to take up space only. Yes, apart from that, all are variables. So sorted list creations, we are going to create the sorted list at max of log n times this function is going to be called, and every time it is going to be create of size of mid. And so I can consider it can grow as big as m. So it kind of like big of m log n space we are using, but it is not m, it is obviously lesser, but it can grow as big as n for at least very last code. So that's the reason I took it again. But yeah, so that is the time complexity and space complexity for this particular problem that I am able to think of. So I know, guys, it is not. Hi guys, sorry, welcome back to it. So today we will solve another question from Leetcode itself. So let's get started. Yes. So I am repeatedly stating it is not a very commonly asked problems at all. But yeah, the problem is kind of a super like master level competitive programming level question. Yes, so I tried my altogether best to explain this particular problem, and if you guys are able to understand till this point, so please do subscribe to our channel, and please share the videos to your friend circles who are also preparing for top product based company and who are also brushing up their DSL skills. And please turn on the notification so that when we are going to live our next video, you will get the notification as soon as possible, guys. As soon as possible. So that's it, guys. That's it for this particular video. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.